We're going to look at example 21. In a sample of 902 individuals under 40 who were or had previously been married, each person was classified according to gender and their age at first marriage. The results are summarized in this two-way classification table. So M means male, F means female, E is the person was a teenager when they were first married, W, the person was in their 20s when they were first married, and H, they were in their 30s when they were first married. All right, and then there's an explanation of what each thing means, but we'll look at what everything means as we go to our problems. Number 1, find the probability that the individual selected was a teenager at first marriage. And number 2, find the probability that the individual selected was a teenager at first marriage, given that the person is male. All right, so number 1, we want to find the probability that the person selected was a teenager at first marriage. Now, teenager at first marriage was symbolized with an E. A teenager when first married is E. So we're looking for the probability of E. Now, let me write that on a separate document here. So we're looking for the probability of E for number 1. And I hate when it does stuff like that. All right, so let's find all the people who have the characteristic of E being a teenager when they first got married and put that over the entire sample space. All right, so if we look back at our notes here. Okay, so the people who belong to this category E, who are teenagers when they were first married, are all in this column underneath E. So the total number of them is 125. So that's the top of our fraction. And then the total number of people in the sample is 902. So it's 125 over 902. Oops. 125 over 902. Now, we probably want to reduce that or change it into a decimal. So I'm going to stick that into my calculator rather than trying to reduce something that large. And I also think that nothing's going to go into both of them. And as a decimal, that ends up being 0.1386. And of course, you will want to pay attention in your homework to how many decimals to round to. I rounded that to 4, but some of your homework might ask for 3 or even 2. So be careful that you watch for that. Now let's do part B or part 2. Not sure which one it was. All right, so our second question. Find the probability that the individual selected was a teenager at first marriage, given that that person is male. Whenever we see that wording given, that's always a conditional probability. And it looks like this. So let me go back to my page here. We're still looking for the probability that they were a teenager when they first married. But we have this additional condition given that they were male. And the notation looks like that. So notice that the given part always goes behind the original probability that we're looking for. All right, so according to our formula for conditional probability, this is equal to the probability of E and M, or let me see if I've got my little intersection sign somewhere. And so there it is. So we'll have the intersection of E and M on top. And I want you to notice that whatever is second in the notation, whatever comes after the line in this probability of E given M, in this case the M, goes on the bottom. So the probability of M. Okay, so let's figure out the bottom and the top of this fraction. Let's start with the probability that someone is or got married as a teenager and also were male. All right, so if we look back at here, let's look at our contingency table. So I go back up. All right, so the probability they were both a teenager when they were first married and they were male. And let's notice that the E and the M overlap right here. There are 43 people who were both male and a teenager when they first married. So that's 43 out of 902. All right, so the top of the fraction, whoops, I didn't mean to go down, but is 43 over 902. And the bottom of the fraction, we need the probability that someone is male. So again, let's go back to our table. And let's notice the males is this row right here. All of these people in this row are male. So there are 450 males out of our 902. Okay, so now we've got a fraction over the top of a fraction, but I want you to notice that the denominators of these fractions are the same. And essentially what's going to happen is both of those denominators are going to cancel. And I just want to show you why, but you can always take the shortcut of just canceling the two denominators. Recall from years ago when we were doing division of fractions, and remember that this fraction bar right here is really a division symbol. So 43 over 902 divided by 450 over 902. Well, recall fraction division, what we always do with fraction division is we take the second fraction and we get its reciprocal, or in other words, turn it over, and then it becomes a multiplication problem. And you might recall from multiplying fractions that we can cross-cancel numerators with denominators if they are across from each other. So in this case, the 902 would cancel with the 902, and we'd end up with 43 over 450. Now, again, rather than trying to reduce that, which probably doesn't reduce, let's go ahead and put it into our calculator and get the decimal. And that gives us 0.0956. Now be careful when you're doing your homework. Realize if it asks for a fraction as an answer, you want to give it that 43 over 450 rather than this 0.0956.